All right, area and volume type 4. In an effort to get these videos short enough to be able to upload onto YouTube, I'm just going to kind of do these page by page. This one has 14 pages, and I'll kind of just talk through the solutions as I've already written them out. So in this problem number 2, it's AB. However, volume and area are not on the AP exam in 2020. So we can expect on the BC that there may indeed be some volume questions. So this one, the first part, you're finding the volume of a solid generated when R is rotated about the line y equals -2. -2 is down here. Okay, and I'm rotating, so I know that I'm going to have a solid piece, and I'm also going to have a hole. Remember, if we rotate that, we're going to end up with some sort of circle here, and here we're going to end up with a hole inside there. All right, so we're going to have big R, which is the height of 4 plus 2. We're going to have little r, which is going to be this area underneath the curve, and then also we're going to have to add this little piece 2 right here. Okay, so that's how I got that 2 plus there. All right, and so you're going to set this up in the calculator. The area of these washers are pi big R squared minus pi little r squared, and there it is. Okay, so I'm going to plug that in. Here's your 6. There's your big R. There's your little r. And then we plug it in the calculator and get either one of these answers. All right, part B tells you that region R is the base of a solid, and it is an isosceles triangle. And I tried to kind of indicate here, we've got these isosceles triangles that, are cross sections. All right, isosceles triangles, here's the area. We know that base and height are the same, so it's 1/2 b squared. Our base is going to be this length, which again is this 4 minus, that little piece underneath the curve, which is right here. Okay? And then again, this is a calculator question. You can leave it left like that, or you can give its final answer right there. All right, part C says set up but do not solve an equation involving an integral expression that gives a solution for k, where k divides this region R into 2 equal parts. And so that region R is going to be defined by from 0 to 2.3, but I'm going to divide it into 2 parts so that from 0 to k is going to also equal from k to 2.3, and you do not have to solve that. All right, question 5 on AB. And again, even though the volume and area are not included on the AB exam, they could be included on the BC exam. So we have this region R defined by 2 curves, both F and G. And so the area of R is going to be the top curve minus the bottom curve from its upper and lower bounds. All right, this is a non-calculator problem. So the top curve is this cosine curve. The bottom curve is the quadratic. And so again, what they're looking for here in this problem is, do you know how to actually find the antiderivative of these 2 functions? I did a little u sub over here in the corner to solve for the correct constant, which ends up being 4 over pi here. Integration of cosine we know is sine, and then we can easily integrate our polynomial by reverse power rule. Plugging in 2, so here is my f of b over here, okay, minus my f of a when I plug in 0. Fortunately, both of those terms is 0. When I simplify this, actually, you can leave it like this on the AP exam. You don't need to go any farther, but the actual answer, all the way simplified down, is 16 pi minus 4/3. All right, part B and part C, by the way, but they say set up and do not, or write, but do not evaluate. So I'm trying to find the volume of revolution of this solid when it's revolved around the line y equals 4. And again, we're going to have, when we rotate that, we're going to have a washer. So we're going to have a big solid, and we're going to have a little hole there. So we're going to have big R and little r. Big R is defined from the axis of rotation, remember, so that's where that 4 is, from the axis of rotation minus the little piece underneath f of x, and then the little r is going to be, again, from the axis of rotation minus the area underneath g of x for the whole. All right, and so I just set up a do not evaluate. Here is my pi, my constant. Here's my big R here, and my little r here. All right. Part C, again, says write, but do not evaluate this volume where the cross sections are squares. So the side of each square is going to be the top curve minus the bottom curve, okay, where that top curve is given by the cosine and the bottom curve is given by our quadratic. And so it's top curve minus bottom curve squared. So there are, you can be hard brackets here. And again, you're setting up but not evaluating. All right, here we go. 2015 AB number 2. You do have your calculator here. And so I would very strongly suggest that you graph it on your calculator to make sure that your picture looks exactly like the picture that's given in the AP booklet or on the exam. You need to find the intersection. They're given 2 points of intersection. You're given this 0, 2 right here, and you're given 2, 4, but you do need to find this point of intersection right here. So I just set the 2 equal, found that intersection, and I stored it in alpha A. So the sum of R plus S, R in region R, our cubic is above our other curve. It's a linear plus an exponential, but so that's R, so that's right here, and that goes from 0 to A. And then from A to 2, we now have our exponential linear function, or the sum of that linear plus the exponential on top, minus the cubic on the bottom. And doing those both in the calculator, and I get a sum of 2.004. Region S has a volume with cross sections that are squares. And again, region S is defined as our f of x, which is our function with our exponential, minus our cubic, because our exponential is on top. And I'm going to square that because each side of the square up here in S is going to have that length f of x minus g of x. Just again on the calculator, and remember you're going from alpha A to 2. Now, the vertical distance, what they're asking for is the change in y, the height. And so h of x, I'm going to define that function as f minus g, okay, because I'm at 1.8, okay, so since I'm at 1.8, I'm in this region S, and so then I'm going to take the derivative because I want the rate at which this distance, vertical distance, is changing. So f prime minus g prime at 1.8. They're in the calculator, so you can do that either by hand, each one separately, or you can do it as, like y1 minus y2 and find the derivative. Okay, another volume problem, 2009 AB number 4. We have the area of R, which is again top minus bottom, so it's the linear 2x minus x squared. This is a non-calculator problem, so again, the AP readers are looking to see that you can integrate. And so we do that, and again, you can leave it as 4 minus 8/3. You do not need to get to its final evaluation of 4/3. Then you have the volume, and the cross sections for this volume problem have area equal to sine pi over x. And so again, we're adding up each of these areas, and so I'm summing from 0 to 2 of sine pi over 2x dx. Did a little u sub down here, and I also changed my limits of integration by just plugging in 0 and 2 into the value of x when I substituted for u. I integrated at negative 2 over pi, cosine u from 0 to pi. Again, you can leave it in its sort of unsimplified form right there on the AP exam, but your final answer is 4 over pi. All right, part C, a little tricky. We have a solid with the same base r, but the cross sections are perpendicular to the y-axis. And because of this, we have to go to the original equations, y equals 2x and y equals x squared, and solve for x, because I'm going to have to write my integration, or my integral in terms of y, okay? And then we know that they're squares, that was given, and so we need to figure out what our s is. And so our side is going to be the far right curve, which is square root of y, minus the leftmost square, which is y over 2, or our line. And so it's right, but do not evaluate. And again, our limits of integration are from 0 to 4 along the y-axis. All right, 2016 AB number 5. Again, this is a non-calculator problem. We're given the radius of our funnel, which is 1/20th of 3 plus h squared. We want the average value, and so we're going to use our average value formula, and we just plug in from 0 to 10, and we integrate, and then again, we can leave it like this. You don't need to get to the 109 over 60 inches. The second part is the volume of the funnel. Now, remember, this volume of the funnel is going to be the sum of all those circular cross-sections. Each of those circular cross-sections has an area of pi r squared, where r is given in the stem of the problem. So we have pi out here. We have our limits from 0 to 10. Here is our r given in the stem of the problem. And again, I factored out that 1/20th after I squared it to get 1 over 400. And then I FOILed that 3 plus h squared, and then integrated, put in my limits. Luckily, when you plug in 0, all of those terms are 0. And you can just leave it like this. It's in inches cubed because it's for volume. Part C happens to be a related rates question. So again, what we're looking for is the rate at which our dH dt is changing. We want to know what dH dt is when h is 3. Well, again, we're given this r equals 1/20th of 3 plus h squared in the stem of the problem. Differentiating that with respect to time, so dr dt equals 1/20th 2h dH dt. And plugging all the knowns in, we know h, we know dr dt, and solving, we get negative 2/3 inch per second is r dH dt. All right, so here is a volume problem, or slight volume problem, BC number 3 from 2011. The first piece is that we need the perimeter of R. This is an awesome problem because it includes a lot of different pieces in one question, and that might be what we're going to see on this year's 2020 exam. So we're asking for the perimeter of R. Well, if I go around this shape, I know this height is 1. I know this length is k. I know this is just the y, or 2 e to the 2k. And then this piece right here is an arc length. So now we need our arc length formula. All right, so I know f. I had to find f prime. So I add these up. 1 plus k plus e to the 2k plus, here's our arc length formula, where 1 plus f prime squared. The second piece was to find the volume in terms of k. The volume of revolution, again, we're going to look at those disks. There's no hole here. And our height, our radius r, is just the height of the curve. And so I get pi r squared, which gives us e to the 4k, excuse me, e to the 4x from 0 to k. And when I integrate that from the limits from 0 to k, I get pi over 4 e to the 4x, and that gives us pi over 4 e to the 4k, when I put in k, minus when I plug in 0. So there is our answer right there for volume. Part C, nice little related rates question. We're using our volume from part B. We know dk dt is 1/3, and we want to know what dv dt is when k is equal to 1/2. And so here's our volume from part B, and I'm going to differentiate using FTC2. So the derivative of volume is dv dt. The derivative of an integral is the inside piece with that function up there plugged in, so I get 4k, and then also have to differentiate that k with respect to t, which is dk dt. So plugging in the things I know dk dt, I know what k is, and I simplify. All right, our multiple choice questions. So I've just sketched, in 83 you have your calculator. I've just sketched what the curves looks like. G of x I called the x plus 5, I called f of x the cubic. we had to add two different pieces together, the piece where the cubic's on top and the piece where the linear function's on top. They intersect, I found the intersections, they intersect at 1, 2, and 5. And then the piece, first piece here, 0.5833, second area is 11.25. Adding them together, I get choice B. Number 10, I'm assuming you don't have the calculator. I just did a little sketch here, what it looked like, and I just want that area underneath the curve, which is just from 0 to 2 of e to the x over 2 dx. Integrating, plugging in 2, and then plugging in 0. And then here's my final answer, which is your choice D. 92 is another sort of region whose cross-sections in this case are squares. And again, we're going to have the top curve minus the bottom curve. That is going to be the length of my side, and I'm going to square it since my area of a square is just side squared. I'm doing this in the calculator, and I got 0.1285, which is choice A. Choice B again would be, number 87, again would be a calculator problem. Again, it's another cross-section where the cross-sections are squares, so it's a volume problem with cross-sections. And here I'm just going to find s squared, and again I use my calculator, and I get choice B. All right, this last problem is one of those which ones are true. So we're given that h of x is equal to h of 2 minus x for all x. We know it's differentiable, and therefore it's continuous. So since it was asking about derivatives, I took the derivative, okay? And I'm going to let, just to look at, I'm going to let x be 1. And so that tells me that h prime of 1 equals negative h prime of 1 when I plug in 1 just in for the x's and the 2 minus x. This is only true when h prime of 1 is equal to 0 if I solve that equation. So we know that choice 2 is true. Now, this is telling us that the area underneath the curve is always positive. And this is not necessarily the case. It could be, but again, what we're probably talking about here is a constant function, and doesn't necessarily always have to be something that is above the x-axis. It could be below the x-axis. And at x equals 0, h prime of 0 is equal to negative h prime of 2, which is the opposite. So 3 is false, and we have that only choice 2 is true.